the lecture second of this week that we have done with this question that particularly tells about your WCWR. Okay, so if you remember this question. Okay, so now in this question there the input alphabet is your A, B, and C if you remember it. So but your W belongs to a string of A's and B's. Keep in mind your W belongs to strings of A and B, and there is a plus there. Okay. So now in this particular question, if you remember that, like if I use a symbol like AB and then there will be a C in between and then there will be a WR, it will be like a ABA. Okay, so whatever written here of W, it will be the reversal of it. Okay, so due to this symbol, I came to know that now we have reached at the center. Now I am able to I will start popping. Now the popping will occur in such a way such that if you push that AB, so first of all we are keep pushing any symbol that are coming there, and when seeing the symbol C, I know that I reach the center. Okay, so I do not push this onto the stack, but after that I will start popping. Okay, so what when my pointer reach here, if there is an input A and at the top of the stack there is A, I will pop it and I will increment the pointer, and if the
Excuse me, sir.
yes, yes.
So can you use a bit of darker ink? It's very light on the canvas.
Okay,
Yes,
it's okay now. uh okay, so if is it visible now?
yes, sir.
Okay. So now when you reach at the top of the stack, first of all, you will keep pushing whenever when you are starting the symbol, and when you reach at the center, you will start popping. Okay, so whenever at the top of the stack there is a and A symbol occur, you will pop it and you increment the pointer, and whenever there is a B here and at the top of the there is a B, you will always pop it, and if you reach a, you will always pop it. See the placement here. Okay, so the placement is in such a way that you will pop, suppose any take a any W. So suppose I take a W like BBA. Okay, so it can also happen that after C the reversal of this is ABB. Okay, so it is designed in such a way that the reversal of it will always be at the top of the stack. Okay, so if this step is followed like this, you will always get a Z naught in the end. If you're not getting a Z naught, you can directly say that this particular string does not belong to this language. Okay, so how it is this possible with the by knowing the center. Okay, so if you know the center, then you know how to pop and when to pop. Okay, so now in this particular question that your WWR, okay, so that is your classic question if you remember. Just wait a minute. Just okay. WWR. Okay, so now this is your classic question if you remember. This is not a regular one. Okay, so this is not regular, you always know this. We have denoted one or two lecture for only this particular thing if you remember the variants of this. Okay, so this is not regular. Now if you see that W belongs to, I can say that A plus A comma B plus. Okay, so now the only problem here that you can if W is ABA and then this WR is again ABA, so you can say then whenever you got two A's, this is your W and this is your WR, that you get your center. Okay, so whenever there is a single A coming and then there is a you will think that it is a center, but actually another scenario is also possible like BBA. Now this is your W and now this is your reversal will be ABB. So this is your WR. Okay, so now if you see B and B is again occurring here, A and A is again occurring here. So what is the center? Is this a center or is this a center? So that is your problem here. Okay, so you cannot, because you cannot build up PDA, more specifically a deterministic PDA for this particular language, but you can build a non-deterministic PDA. So how can you build? So there will be at, if there are symbols repeating something like this A. Okay, so now how will this non-deterministic PDA comes into play? Okay, so first of all, when it occur the symbol again, first step will assume that it's a center. Now it's a center reached. Another step will assume that it is not the center and it will keep going. In the similar way here, it's also double A. Now again here it's also assumed that it's a center, and again it's assumed it's not a center. Okay, so that is how you solve this question. Okay, so I'll tell you more that what exactly but what exactly I mean by that. Okay, so I just try to draw this non-deterministic PDA. Okay, so the only difference between PDA and non-deterministic PDA is on the same input. Okay, so keep in mind, on the same input two different path will be defined. Okay, so that definition is same as the non-deterministic push at the non-deterministic DFA. It's the same as, because if the same input is received, in particularly in DFA, if something like this occurs, suppose there is A, on A it is going towards the state Q1. In the similar way here, there is another state that is again getting an input of A, it is going towards another one. So that is your NDFA. More specifically, NFA is also this is also a NFA. So on the same input, it is going towards two different state. Okay, so in this context, it will basically look like this, that you are at some state, something like if you got input of A, and at the top of the stack there is a Z node, and you are suppose there is something like this. Okay, so at the top of the stack there is A again, and you are pushing that A, so you are going towards the state 2, and in the similar way it will be again A, and at the top of the stack there is A. Okay, so now the input is same, but in this particular context you are popping it. Okay, you are popping it. Okay, so if you're seeing the input here and the stack symbol here and the stack symbol are same. Okay, so the action here and action here is different. Okay, so these two things represent, if you remember, the what is the exactly transition symbol for this one? It was Q into is there was a input alphabet as well as there are epsilon. Okay, so epsilon is for the final state, keep in mind, and then there is a tau symbol. So tau is your stack alphabet. Keep in mind the stack alphabet can be different from the input also. Okay, so it can also happen. So I say that by getting an input of A, I am putting X towards the stack. X towards the stack. Okay, so in this particular questions, I am always using the stack symbol as similar to the input, but it can be different also. So the meaning will be same, that by seeing input of A, you are putting X in the stack. Okay, so keep in mind that it can also be different. So the meaning will be same. Now it is going towards 2 raised to power exactly what was is at a set of state, and you can change the stack. Okay, now now it is saying that it can go towards two different states, and two different actions can be performed. Okay, so if you are seeing two different, this is a state Q2 and this is a state Q3, and two different actions, and two different action is here it is pushed, and in this particular context it is popped. Okay, so that is your NDPDA. Okay, so that is why NDPDA is more powerful than PDA, because PDA or DPDA. Okay, keep in mind, I will not explicitly in any book, if you take out any book, they will not explicitly use the deterministic PDA. Okay, so PDA or DPDA is one and the same thing. Okay, so the expressive power of non-deterministic PDA is more than the expressive power of deterministic PDA. So that is why there is no conversion between that. Okay, so the conversion is only possible if the expressive power of both of these automatas are similar. If you remember in DFA, if DFA, the expressive power of DFA is equivalent to the expressive power of NDFA, so that is why we are able to convert NDFA to DFA and DFA to NDFA. Okay, so that is why. But in this particular context, this push down automata cannot accept this WWR. It is only accepted by non-deterministic push down automata. So that is why the expressive power of this is greater than as compared to the deterministic push down automata, and the conversion from DPDA to NDPDA is not possible.
Excuse me, sir.
Hello, Hanji.
So, what do you mean by more powerful? Like it has more outcomes, that's why it is more powerful, or what?
No, no. If you see, this particular DPDA will not accept WWR. Okay, but this PDA will accept a WWR. Okay, so in terms of languages, it is accepting more languages than DPDA. So that is why it is more powerful.
Okay.
So in that
Okay.
context, I'm saying. Okay. So now, just get to the automata. I will show you that how it is actually doing. So first of all, keep in mind that there will be two possibilities. Okay, so if I am taking this as input b, because if you're seeing WWR, most of the time you will be thinking that if your string is ABA and the reversal of it is ABA, so whenever two strings are repeating, so something like this BAB and BAB, so most of the time, whenever there are two things repeating, so we will say that a center is reached. But this string can also come where W is BB and WR is also a BB, because the reversal of W is also a BB. So I have to assume that in this there I have to assume two things. Okay. First of all, here I will assume that center has come and you start popping, and another outcome will be center has not come, you start pushing. Okay, so I'll tell you how. So if I understand, just wait for a second. Okay. So sorry for that. We will take two possibilities here. So first, the center has come. Another one, the center has not come. Okay. So just let me start the automata. Okay. So now it will be look. First of all the possibility has to be taken care of. So I am assuming the worst possible case that is there. So the worst possible case that can occur is four A's and four B's. Okay. So now what will happen? Okay, so just wait for a second. Okay. Okay. So now there is a queue node here, and then what you assume that first of all your stack is empty and number of A's are coming and number of B's are coming. So first of all, I'm assuming A is coming and a B is coming. So what you do, you just keep pushing it. Okay. Okay, so there is a when A come and then there is a Z node, so you will push A Z node. Then it's also possible that B can also come in the starting. So if you put there is a B, you push B and it will become BZ node. Okay, so this is your first scenario when a number of A's and number of B's are coming. Okay, so now what you do now the problem lies in the second B. Okay, so whether you assume it's a center and rather you assume it's not a center. Okay, so first of all you assume that it's not a center and you keep pushing. Okay, so for that there is a B coming and at the top of the stack, if there is another B, you keep push it, and then another one, if there is a come and at the top of the stack there is a, you again keep pushing. Okay, so it will be a. Okay, so for a different symbol, this is when there you are assuming that there is no center. Okay, so for center, so now you will also assume, you can also assume that it's a center has key. Okay, so what you do, you will change the state now. Okay, so you assume that a, now for seeing a second a, and you are assuming that it's a center and at the top of the stack there is a, you start popping it. Okay, in the similar way, for this particular scenario, there is a b. So there is a B and at the top of the stack there is also a B and you start popping it. Okay, so if you're seeing A input and the stack symbol is similar, but the action is different. Okay, so it is pushing here, it is popping here. So there are two possibilities. First of all, if I assume this if I assume this particular thing A, and then there is another thing B. So always there is, when there is a repetition of the symbols and there is a repetition of the symbol, either it will be a center reached or it will not be a center. Okay, so first of all you will do like this. In the first scenario you will push the A and the second A come, the second A either, now this will become a either or part, or you can push the A assuming that it's not a center, or you can again pop the A assuming that it's a center. Okay, so actually the center is here, but how can we tell the computer that we have reached the center? So that is why we are following that part. Okay, so now it is saying a center has reached. Now it is saying a center has reached and it will start popping, and it is saying that no center has reached. Okay, so also take care of other possibilities, that if there is already a and B comes, so you will start pushing it. So I am again I have to take care of this possibilities of if there is a and at the top of the stack there is a B, you just start. This is a very simple, because if the symbol is different from this one, so you have to push it. So that is very clear. If there is a B at the top, if there is a B coming and the top of the stack there is a, then you again push it. Okay, so that is for first state. These are your possible income. Now these are your possible states. Now see here, the non-deterministic part is defined by this particular transition. Okay, so on input and stack symbol, in both of these inputs are same. So that is why it is called a non-deterministic push down automata. Now what will happen here? It will just start popping. Okay, so its main concern is that now the center has came and I am again I am just popping it. Okay, I will solve the example, don't worry about that part. And now there is a it will start popping. So in the end you will reach if the number, if you have reached the center, in the end you will reach in the Z node. So you just go to the final state. Okay, so that will be your non-deterministic pushdown automata. Why I am calling this a non-deterministic pushdown automata? Because at the same input and stack symbol or stack alphabet at the stake, it is also called as the state input, and it is also called a stack input. So it's also termed as a tau, right? Okay, so for the same input and a tau, for the same summation, for the same sigma and tau, it is going to two different states. Okay, so it is at BB, it is staying at Q node. At BB, it is going towards the Q1. Okay, so now how to interpret this one? Just see. So now I will take input, that is your this one. Okay, so this is the worst possible case that can occur. So here we will reach the center, but actually here we will reach the center, but it will assume that either a center has reached starting from this state. Okay, so how this will run? So start. Okay, so now you are at the state. Now this is your input. Now you are at the state Q node. Okay, suppose you are at the state Q node and you got input of 4 A's. So I'm assuming that there are 4 A's as input and you are at Z node. Okay, so now I will consume 1 A. Suppose I will consume 1 A. Now the remaining part, so it's very simple, because if you're seeing the input is these 4 A's. Okay, so the input I'm writing like this, but actually it means Q node the input is 1. Okay, so at every step one input will be consumed. Okay. Now see, you got an input of A. Now your input will become 3 A's. Okay, so one input is consumed, now it will become 3 A's. Now what is the step here? That you are at the state q node and z node is at the top of the stack, and you know you got a. Okay, so a z node, but you will do, you push the a, so it will become a z node. Okay, so now keep seeing what exactly is happening in this particular context. Now see, now the okay, so now the input is again A here. Now input is again here A. Now there are two possibilities. Whether it will be one possibility will be that it does not reach the center. Another possibility will be it has reached the center. Okay, so if there is a no center at the top of the stack, there is a and at the top of the stack there is okay. So just for this particular context, the stack will become Z naught, it is at the top of the stack and we have pushed I. Okay, so now in this context there is a Z naught and then there is a and another A is inputted, so it is assuming that it's not a center. Okay, so it is assuming that it's not a center. So when you see a input A for not center, it will push it. Okay, so when you see the input A and at the top of the stack there is a, you will push it. So what I'll do, I'll do q node and I will consume 1A is consumed, so it will become 2A's and then it will become A. So I'm again writing all the contents of stack, so you do not get confused in this. Now I'm writing just to be clear, I am writing all the contents of the stack and all the inputs, so you do not get confused. Okay, so now in this, if no center is reached, I will push this A. Now if the center is reached, what I will do, I will pop it. Okay, so now it will go towards the state q1. Now it will go towards the state q1. It is saying it will pop the A. Okay, so if by popping the A, it will become the inputs are consumed as 2 A's are consumed. So by popping it, it will become only a Z naught. Okay, so now at q1, if you're seeing at q1, it is standing at q1 and the stack is not empty. Okay, so it cannot go further there, it will always just sit here. Okay, so because if you see at Z node and when the A comes, another input A is coming, the move is not defined here. Okay, so at q1 there is no move like you are standing at the state q1 and A come and the top of the stack there is a Z node, so this move is not defined in q1, so it means this string is not accepted. So you stop here and again keep moving here. So again there will be two possibilities here also. First again the A will be consumed. Now it will assume that no center has came and it will assume actually here the center has came. Okay, so it will assume the center has came. Now now in this particular context, what will happen, it will again push it, so it will become, it will stay at q node and it will become one input is consumed, so it will become only one A is remaining and it will push triple A's on the Z node. Okay, so now if it assumes that the center has reached, what it will do, it will keep popping it. Okay, so it will reach q1, and it will pop, I think it will pop. Now only one input is remaining and it will pop because here just let me write the stack for both of them. So the stack here for this one is A and then A. Now A is coming. Okay, so in this particular context I have again pushed the A. In this particular context I have to pop the A. Okay, so just why I am doing here. Okay, so for this particular context, this is Z naught, this is A and this is A. Now A is coming, so I have to pop this A, so the stack will be a Z naught. Okay, so now again check for this, again it will assume that it's a no center or a center. Okay, so now in this particular case the last input will be consumed. Now it will again push it. Now the stack here is Z naught, A and then A, and A is coming. So I don't think that it will lead to anything because all the inputs are consumed now, so there is nothing here and the stack will contain A, Z naught. So this move is not defined here. The Q node, you are not reaching at the end state, so you can say that this is not accepted. In a similar way, if center is reached here, it will become Q node. Now if in this particular context you will pop that A, now the remaining will be A Z naught. So this is also not reaching the final state, all the inputs are consumed. But see here, this is again a center, and it is assuming that center has reached, it is at state Q1. Now at Q1, if you remember, at Q1 this is only start, the all the popping is again, there is a loop of popping, so it will start popping. Okay, so now at Q1 you will see what it'll do, it will stay at Q1 and it will pop this Z node also. Okay, so it will become a Z node. Okay, so now if you see the for this particular context, the stack was, you have the stack was A Z node and you got another A. Okay, you got another A, so all the input is finished now here. And if this is a center, because we are at the state Q1, it will start popping. Okay, so it is a loop of popping. So what it'll do, now you are here Z naught and another A is coming, so you will pop it. Okay, so that pop. Now you have reached at the Z naught. So what exactly is happening, you are at state Q1 and you got Z naught. Now this particular state is defined at Q1. So if you're seeing Q1, at Q1, for if you reach a Z naught, you can move on to the final state. Okay, so that is how this NDPDA is working. Okay, actually. Okay, so it will at every step it will assume either a center has reached or a center has not reached. Okay, so that is why it's a little bit of a difficult, and it is expressive power is much larger than, is much more than a plain deterministic PDA. Okay, so every step, if you're seeing where the non-determinism is showing here, so there is your non-determinism is showing. Okay, so at this step it is going towards two different states, and here also there is also, you are seeing non-determinism, here there is also a non-determinism. Okay, so that is why keep in mind that the non-deterministic pushdown automata is always more than more expressive, has more expressive power than your deterministic push down. Keep in mind, this is a very important thing. Again, when I use a PDA, I only use a PDA, it actually means a DPDA. Okay, so it always keep in mind, whenever there is a PDA written, it actually means a deterministic PDA. They will not write it differently. Okay, so they will not write it differently. A PDA or a DPDA is one and the same thing. But for non-determinism, they will always give you a NPDA. Keep in mind these two things. Okay, this is very important because many of the students will get confused in that part, that the deterministic portion is not defined. Okay, so keep in mind, I learned it the hard way that if there is no D in front of it, it means that they are talking about a DPDA. And if they are talking about a PDA, again, if you now your acceptor set will become a finite automata, and then there is a more power is your PDA or DPDA, and then the another one is your NPDA. Okay, so if a language is accepted by a finite automata, if a language is accepted by a finite automata, it will be accepted by a DPDA and NPDA. Keep in mind, if language is accepted by, if the language is regular, it will be accepted by finite, DPDA, or NPDA. If a language is accepted by a DPDA, it will always be accepted by a PDA. Okay, so it will always be accepted by a, sorry for that, it will always be accepted by a NPDA. If a language is accepted by an NPDA, so there is nothing there, so it will only be accepted by an NPDA. Keep in mind. Okay, so because DPDA is a subset of NPDA, so if any language is accepted by a DPDA, it can be done in a non-deterministic pushdown automata. But if a language is accepted by a non-deterministic pushdown automata, it will not be accepted by a DPDA. So the classic example of this was a WWR. Okay, so WWR is accepted by NPDA, but it is not accepted by a DPDA. Okay, so in this particular context, if you see, WCWR is accepted by a DPDA and it is also accepted by a NPDA. Okay, so if always, because if you can do everything in one step, you can always do it in two steps. So again, the same context is here also, that every DPDA is NPDA, but the reverse is not true. Okay, so same thing is here. Okay, but the reverse is not true. Keep this thing in mind. Okay, but if you remember, uh, in push down in DFA and NFA, they are both equivalent. Okay, so keep in mind they are both equivalent. So every DFA is actually a NFA, and every NFA can be converted into a DFA. So keep that thing in also your mind. Okay, so now this is the example of DPDA. Now our next problem now arises is your identification. Okay, so we have done a very a number of questions for identification of regular languages. Now I've changed this problem to identification of regular as well as deterministic CFL, as well as also non-deterministic CFL. Okay, so the if a finite automata can be built for a regular language, it can be a regular one. If you can build a DPDA for a CFL, then that language is a CFL, and if you are able to build a non-deterministic PDA for this one, and that particular language will be a non-deterministic CFL. Okay, so without wasting any time, I just show you the questions that we want to do. Okay, so now the more you do this question, the more you will get it. Okay, so the first question is a fairly basic one. I think it's a classic example. It's a classic example. Now you have to just a little bit, just wait for a second. What exactly is happening? Just okay. So the first question is a fairly basic one, and tell me, is this a regular one? Okay, so tell me, is this a regular language, or a context-free language, and a non-context, non-deterministic context-free language? Let me take. Okay. So there is no need to draw a particular push-down automata for every question. You can easily take a stack and think about it. Okay, so you can easily take a stack and think about it if it is possible or not. Okay, so now I just say if I can take this whole table in one object if possible. So it is pasting. Okay, so I think it's a bit of so the first question is based on that a raised to power and b raised to power n, it is not a regular language. If you remember, it is not a regular language. And for CFL, it's a CFL. If you remember, we have able to draw the push down automata for this particular language. So this is a CFL as well. If it is a CFL, it is automatically a NDFA, because NCFL is a superset of CFL. Okay. So now in this context, if you can tell this is a regular one or not, so tell me about this regular. You just have to reply like no, yes, 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 no, no, yes, yes. Okay, so just participate in this one, so you will get to know more. Okay. Yes, no YY. So this is not a regular language. Absolutely correct by Jagan, Varun, and Adarsh, and Mayank also. So this is not a regular language, but we are able to draw the context free, because I will tell you in the tude that how we can draw. So also I can tell you now, if for this particular language a raised to power n, b raised to power 2n, what you do, you take a stack. Whenever there is a coming, suppose there are one a, there will be two b's, so there are two a's, there will be four b's. Okay, so there are two ways to solve this. So whenever there is one a coming, you can push two a's. Okay, so for that you can push two a's when there is a one a coming. And for this A, you can also push two A's. For now, after seeing a number of B's, you can directly pop it. So at the end, it will be the same thing. Okay, so another case can be Z naught. When you are seeing a, you push it. When you are seeing a B, you push it. And when you are seeing two B's, okay, you can pop a one, but that will become a little bit complicated. But I think that will be a good solution. But also there is another solution can be, when you see two B's, you can pop one A. When you see two B's, you can pop one A. Okay, so we will do, don't worry about it, we will do more questions in Tude, but this is how can
Sir,
you do
in the second method, is it like is there any space like it is space efficient, right? The second one, like we will use less space of the stack
Yes, yes,
in the
yes.
second.
You will use less in context of the stack, but that is also possible. That is not wrong. So there is, if you want to save space, you can do it, but there is no particular algorithm to define that which one to follow. Okay, so you can follow anyone, because uh, if you're seeing the stack space is very little, okay, so always there will be a very little uh, problem in that, but we will always concentrate more on the time complexity. Okay, so if you're seeing data structure and other things, there is also a space complexity, there is also a time complexity, but nowadays we concentrate on the time one more, because space is becoming more and more cheap. Okay, so that is why. So you can follow in any other one. This will be more efficient way. So you can do this also. Okay, so don't worry about it. We will talk about this in the tute. Okay, so this is again no, yes, and yes. Okay, so just see. Okay, so I can also write it here in the word. Okay, so now check this this question: a raised to power m, n, and n. Okay, so if you're thinking about, so it is not regular, you can directly say that that is exactly true. And I think Varun has again given the right answer, because if you put it in a stack, so the A is not dependent upon B and C. So you do not push this A onto the stack. You will directly push a B, any number of B's. After seeing a C, you will pop it. Okay, so that is how to build this one. You can say this is a CFL, and that is how this is also a NCFL also. Okay, now see this next question. It is a bit different. Now you're seeing there is a. I think we have done this question in yesterday. Okay, so tell me about this 3A. Is this, what exactly is the answer here for 3A? Okay, I think that is absolutely correct by Adarsh, Varun, and Priya also. And again, if you remember, you do not push this B onto the stack. Okay, so for number of A's, you will push whenever there is a B occurs. You do not push it on the stack. You just rate the stack. The stack will remain as it is, but whenever C comes, you will start popping it. Okay, so this question we have done previously. So this is a context. This is, we can draw a deterministic push down automata for this one. So the NDFA is also possible. Okay, now see for 3B. Okay, 3B. I think it's also a similar one. You do not put this on the stack. Okay, so I think the same answer is here. So no, yes, yes. Okay, so again in this context, you push any number of A's, and then when there is a B coming, you will pop it, and there is no need to put a C onto the stack. Okay, so that will be your answer. Now see fourth one. This is a more interesting question. If you are seeing now, it will take a little bit of a thinking to understand this one. Okay, so just try this fourth question and tell me what will be the answer. Okay, so I think Jagan again got the right one, that it is again, it is not a regular one, because there is a dependency M and M. So you can directly say this is not a regular one. But now how to solve this? Okay, so there are many possible scenarios here. First of all, when there will be a number of A's will be coming at Z naught. You will keep pushing it. After a B come, you will start popping it. Okay, so after a B come, you will start popping it. Now there is another chance that there will C come, and at the top of the stack there will be Z naught. Okay, so this is another third possibility, that when you, because if the number of A's and number of B's are equal, you will reach at Z naught, and then you again for this, when there is a C input and at the top of the stack there is Z naught, you have to again push C, and for D you have again have to pop it. So that is why you can again build a deterministic push down automata for this one. So that is why this is yes, and this is also yes for this one. Okay, so check 4A. I think it's a little bit of interesting one. So just let me zoom it also if you are seeing. It is absolutely sure that this particular is not a regular one. So that is particularly sure because there is a P and there is a P. You can directly say. I think someone got the answer here. Okay. Okay, 4A is no, yes, yes, absolutely. Okay, so in this context also you will push A, you will because A and B are equal, you will pop on getting a B, then you will push C because C and D is also equal. For seeing a D you will pop D, you will pop C, and for E and F is also equal. For seeing a E you will push C E, and then you will pop whenever there is a F here. So that is also possible. So that is why it is deterministic push down automata is possible in this case. So that is why NDPD is also possible. Okay. So now see this question. I think, yeah, just take a little bit of time. I think it's a tricky question. Okay, so that I will tell you the answer. Tell me about the fifth one. Take a little bit of time to form a stack. Okay, so already the answer is no, yes, yes. Okay, so just let me take a look. This is not a regular one. It is absolutely sure. So for Z node, I can push A, but after that I have to push B. Yeah, absolutely. After seeing C, I have to pop B, and after seeing D, because A number of A's and number of D's are equal, so after seeing D I have to pop D. So I will reach a Z node. So the deterministic automata is definitely possible for that, and you can say this is no, yes, yes. Okay, so I think this is a interesting one. Okay, so see the sixth one. Try to run a stack. Don't do it quickly. Just take a little bit of time to form a stack. Okay, so I think Ishan has also given the answer as no, yes, yes. Okay, so just let me verify it that it is possible. So the number of A's and number of C's are equal, number of B's and number of D's are equal. Okay, so first I'll push A. So for there is a Z naught, I will push A for B. Okay, so that seems a little difficult one. So for B also I will push B, and then C the number of A's and number of, I don't think I can build that. I don't think I can able to build this one. So just let me verify this.
Excuse me, sir.
Yes, yes.
Sir, can we use two stack for
No, you
storing?
cannot use two stack. You can only use one stack. That is a compulsion.
So we can push A and B and then pop C and D. Then we will get empty, sir.
You can push A and B, then
Yes. So there will be m plus n elements, and then when we encounter C, we remove last m elements, and then we encounter D, we remove last n remaining elements. So we will get the empty
okay,
stack.
suppose there is a scenario like a raised to power 3 and b raised to power 2, and then
Yes.
c should be equal to this one, and then d should be equal to this one. Okay, you're seeing
Yes.
3 plus 2 and 3 plus 2. That is absolutely correct. Now
Yes.
for that one you will push 3 A's. Okay, absolutely. You will push 3 A's and you will pop 2 B's for that one. And for C, now this is the problem there now.
No, sir. No,
This,
no. I'm saying we push
okay,
three
okay, okay,
A's and then we push two B's
okay,
and then we pop three A's. Sorry, last three elements and then last two elements like
okay.
that.
So there will be 3 A's and 3 B's. Okay. So now
Two
for
B's, two B's, two.
yeah, 3 A's, 2 B's. For C,
Yes, sir.
I will pop a B. For second B, I will pop. And how can you define this one? That I don't think that possible, because if you are popping it, you will pop to one thing that it will pop to B. Okay, so that is an interesting question. So why do not I try to make a push down automata for this one? I don't think that it is possible here, but just let me confirm. Okay, so what is the question here? A M B N A N B M C, CM and DN, CM and DN, CM and DN. Okay, so okay, so I will think that first of all, there will be a and at the top of the set there is Z naught. So I will push a Z naught, and if there are number of A's coming, it will be, I'll just keep pushing. Okay. So for B also, if there is a, always it will come after B. So for B, it will be,
Sir,
yes, yes.
sir, this is not the question.
This is,
Like the question is different. It is to the power m, not n.
okay, okay. So I think, okay, okay. So this is M and this is N. Yeah.
Yes, sir.
Okay. So now for B, what I'll do, I will again push it. So the pushing will be here, B at the top of the stack, there will always be a and then there will be a B. Okay, so every now A and B's are pushed onto the stack. Now the problem will occur here that after, suppose, after seeing a C, after seeing a C, and at the top of the stack, there will always be B. So I will pop it, yeah. But after seeing a C at the top of the stack, there will be a B, and again I will pop it. Yes, that is possible. So in that context, again, I will say that if there is a D coming here, and at the top of the stack will be what? Top of the stack, it can be a B, but it can be a also. So suppose this is a little bit of a difficult thing. Okay, so suppose in this
So
particular
can
context,
it is compulsory that you have to pop only one kind of element when for like it has to map, like C has to pop only M, it cannot pop B.
yeah,
Is it like mandatory?
this is not particularly uh, no, no, this is not particularly restricted here. You can put pop anything. So just let me verify it. So if there are
Yes.
three A's and two B's, I'm one scenario will be different here. I think because the number of B's and number of C's will change. Okay, so I'll tell you there are two scenarios for
But
this
sir,
one.
excuse me, sir.
Mhm.
Yeah, so in the stack, sir, we'll always pop the top element, right? We cannot just pop anything. Like in this question, it will always be a B on the top,
It will
if we
always
consider
be
the
C.
sequence.
Yeah, when C comes, it will always be B on the top.
Yes, sir.
And because there is three C's, so I will pop this B, pop this B. Okay. So now the scenario will be one C is remaining and here it is a E. So that scenario. So I will say that when another scenario I'm defining that if a C comes and at the top of the stack there is a, you will again pop it. So I think, yeah. So for that one, I have taken care of this one. Now d raised to power n. So now the d is equal to the b. So what are b? b are 2's here. So now what I have to do? Again, I have to change the state. Now d is coming and at the top of the stack, there can be a. Okay, so only a is remaining in this particular context. Okay, so it seems correct, but this is for a particular context. Okay, so if I change the question, something like a is 2, b is 4, c, now there will be a problem in this one. Okay, so c, suppose because m, this is a 2 here and d will be a 4. Okay, so for that one, what I'll do, I will a and then b, b, b. For c, I will pop it, and now for d, now
So
the
there are
top of,
four D's. There are four B's.
there are four
Four
b's.
B's.
Okay, so there are four
So
b's.
2 plus 4 and 2 plus 4, so it will always be empty. We are
No,
pushing six elements and then we are popping six elements.
no, no, you
So
are,
I don't think there will be an issue.
just see, just see.
Excuse me, sir.
Yes, yes.
Sir, if we take an example A2, B4, C3, D3, then this will be not
A and
be,
A and C are equal. A and C are equal.
but
So
it will
here,
accept
take this
also
example
those
also
lambda.
now. So see this one that now D is coming. Now D is coming and B is at the top of the stack. So see here we have not defined anything here. Okay, so we have not defined anything here. For that one, we also have to define this particular context. Okay. So just let me verify it, but I don't think it's a possible. I'll try to build a PDA if it is possible. I will explain you in the next one. Okay, so just wait for a second. But I don't think, actually don't believe it's possible. But I'll tell you in the next one. Just making sure by writing all the states. Okay. So okay, so your quiz was also there. So just let me share you the link. Okay.